the recording. So there's a few things. One, we just want, knowing about pipe is really important because a piston is essentially a piece of pipe with something that goes back and forth inside it that's sealed. Okay, you just saw that. So the size of the pipe is a big deal. A huge piston is going to work with lots more water than a small piston, but we like, if we can, to make things out of pieces of pipe that already exist. So I'm going to make a copy of this and work off of it. So let's say in my piston, I used 1/2 inch pipe. Yeah. The screen isn't sharing. Darn it all. Okay. Thank you. I hate it when I jump back and forth and I can't go. There we go. Now I'm sharing it. So here we go. I need to know this pipe size. So I'm going to say that it's 1/2 inch pipe, and that I'm going to use something called Schedule 40. Now, where would I learn about that? Well, pipe dimensions. That's why I put that in there. So you're gonna look around at all these things. I remember seeing pipe and schedule, ID, wall thickness. So OD, ID, wall. So you can tell that these are important things to know, and you can just fill in your table. So if I made it out of 1/2 inch pipe, schedule 40, I've got information. So I got it. And look, when you're doing a design, you just have to get in here and go, well, I wonder what's available. I wonder what I can buy. I wonder what's useful. And this is for, I don't know what kind of pipe it is. Okay. It should tell me what my material is, because different materials are different things. So this isn't telling me what type of pipe it is, but I think that this is standard steel pipe. Okay. So you'd want to maybe double check what different types of materials there is, or what these guys make. Okay, let's see what kind of stuff they make. Man, it sure looks like it's steel pipe, right? So, because that looks like steel. So theirs is a steel pipe size. These are bleed rings and all sorts of stuff like that. Okay, so let's get back to our calculation then. I'm going to say that I'm working on 1/2 inch pipe, and I've got steel. So what was the OD of a 1/2 inch pipe? OD, outside diameter. And I gave you a video about the terminology. You'll have to look at it. But here's some more. How do you interpret this drawing? What's the OD? What's the ID? Things like that. 0.840. And then what's the ID? It says the ID for Schedule 40 is 0.622. Keep getting to the wrong one. Here we go. 0.622. And then I'm just going to pick some length. How long do I want this to be? I don't know. I'm going to say I'm going to make it out of 4-inch long. So what's my wall thickness? Well, I can calculate that, but in this case, it told me my wall thickness is 0.109. So I'll just type that in there. Or I can say, because I looked at my pipe stuff, what does it equal? It equals my outside diameter minus my inside diameter. But that's all the way across, and thickness is halfway across, so I want to divide by 2. So do you see what I just did there? Oh, 0.109, it came out the same. Okay, and if you look at their thing over here, if you take the outside minus the inside, that gives you all of the brown, and so I have to take half of it. I just want that. It's the outside minus the inside, and take that number divided by 2. And so you're supposed to know by now a little bit of how to use spreadsheets. And so I just used this number right there. And I don't know if I can make that bigger. There we go. Outside minus the inside, but I got to take that whole entire result. So I put it in the parentheses. Divided by 2. Now, what's my area of the inside? I want to know the area of this inside part. I just want to know. It's going to be important to me. So that's pi d squared over 4. And so I've got that in these pipe calcs that show you how to do it. But pi is a number, so I'm going to say it equals, and it's just a number, 3.14, times the diameter squared. I want the inside diameter. It's that cell times that cell, pi d squared divided by 4. 0.303 square inches. So I just put in my oopsie. Darn it, I hate it when I do. 3.141 is pi. That's the inside diameter times the inside diameter divided by 4. And I don't need this many decimal places. I'm not that interested. That looks fine. Now, pipe material cross section. Now that's a little bit interesting. What that is, it's my outside area minus my inside area divided by 2. So what's my outside area? Equals 3.14 times outside area times outside area divided by 4. And I'm going to call that one whole number. So I'm going to put parentheses around it. And then I have to subtract this number I got right here, my inside area. And again, that's a whole number that I just found. And so then I have to divide, that's my pipe. That's it right there. That's my pipe material wall cross section. Outside area minus inside area. That's a number that's going to be important to me when I start talking about how much things cost, how much things weigh, how much. It's going to be an important number sometime. Now we get on to my volume calcs. What is the volume of that inside portion? volume is area times length. It equals area times the length. There we go. It's 1.2 cubic inches. And my pipe material volume equals area times length. So why would I want to know that volume? It's important for calculating weight. It's important for calculating strength. It's important for calculating cost. I don't care about those things right now. I just want to know about them. I want to know that you can calculate them. Now, what's cool is once I've got this set of calculations correct, I can go to, I wonder if 3/4 inch pipe schedule 40 will be okay. So I can go back and I can go 3/4 inch, 1.050. And the inside diameter is 0.824. And let's say I want 4 inches of that too. Now I don't have to do any work. I just copy that down. And I have my numbers. What if I want 1/2 inch schedule, 1/2 inch pipe, schedule 10 steel pipe. So you see how this works. Now I've got a tool that I can go look things up. 1/2 inch schedule 10, 0.674. That's the only difference. 0.840, 0.674, 4 inches long. Now I got stuff I can start making decisions about, because I can tell you the cost of this pipe is going to be less than the cost of this pipe because the material volume is less. And that's not a big deal if I'm just making a few of these, but if I'm using 1,000 feet, it's going to be a big deal. So that's how I do those. Okay? That's how I do those calculations. Does that make sense? Any questions on that part yet? Okay. Yeah, yes. Yes, so there's a whole bunch of ways to copy. So I can highlight, edit, copy, edit, paste. I can copy that way. I can highlight, right-click, copy, right-click, paste. And in different browsers, it's a little different. I'm in a Chrome browser. You have to look and see if you're in Firefox or Safari what you do. Okay? But also in the Chrome browser, I can highlight a set of cells, and there's this tiny little box down here on the corner. I can grab that box, hold down my mouse, and drag it down. Isn't that cool? Yeah. Right. 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 Yeah. Yeah. So it's kind of nice. And like that way all you have to do is put in this. And if now let's see what happens. What if you want all this? I'm going to go Control C, Control V. And what if I want to change those all to 8-inch just to see? Now all of a sudden it's like, yeah. So now, so Alex, you know about generative design. This is the basis of it. If you go, okay, I want to know if I need bigger, I need to know smaller. What if I change lengths? What if I change diameters? What if I, and all of a sudden, these things can be used to generate a cost, to generate a weight, right? To generate whether it's going to float or not, right? Yes, indeed. Back in the day, I had this thing up constantly, and I was always typing in the wrong numbers. I'm pretty good at typing in wrong numbers. Um, so, yes. Does that help out? Right, right. And I've tried to explain them in these about what these calculations mean, but now you know. So now let's take a look at this one. Okay, I've got some of this. Let's say I'm going to use half inch schedule 10. I'm a control C, control V person. Oh, and I don't care about that. I'm just going to put this information right here. And my stroke length is essentially the length. And let's say I'm going to do, man, I'm going to pull 8 inches. And if you think about pushing and pulling and water going in and water going out, I'm going to say I'm only going to do that 4 times every minute. I'm going to take 7 seconds to pull back, wait just a half a second, 7 seconds to push forward, wait half a second. And that might be moving pretty fast, but now I want to get what is that volume? Okay. Well, let's see. Volume of this. Do I have that up here? I do. I've got my internal stroke volume in cubic inches right there. I can say, okay, I'm going to make this a little smaller so that you can. There's my internal volume. So let's say what I want to do is say this right here equals that one. And then this one equals that one. And this one equals that one. And this one equals that one. So I've set this up. So what is my internal stroke volume? It equals internal volume. It equals that. I can just say it equals that one. Got it. I'm done. And now, 4 strokes per minute. I'm going to do it equals this volume times 4. It's that volume 4 times per minute. Bink. Got it. Already I've gotten all I've had to do. Say this equals that, this equals that, this equals that, this equals that. And then find the calculation that I'm interested in. So this is going to do 11 cubic inches per minute. Well, I don't really know in my brain what 11 cubic inches is, but I sure know how big a gallon bucket is. And I was talking to Jan earlier, is I don't know how much I really need yet. It depends on what type of test is going to happen. If I need a few drops on a little sample, I don't need that much. 11 cubic inches in a minute will be fine. But maybe I need a gallon and I need to take it back to the lab. So let me see. I need to know cubic inches, how many gallons is a cubic inch? How many gallons is 0.11 cubic inch. Where is it? How many? Well, it's giving it to me backwards. Let's see. Cubic feet. I bet you they'll have a cubic inch one. Cubic inches to gallons. There it is right there. Cubic inches, about 11. 11 cubic inches in gallons is 0.04. Boy, that's not very much. I can say it's 0.05 gallons. And it'll even tell me how to calculate these. Sometimes you can go and it'll tell you the calculation to you. Okay, but I can just come over here, 0.05. Close enough. So if it does 0.05 gallons in a minute, how many will it do in an hour? Well, there's 60 minutes in an hour, so it's going to do 60 of those. It equals this number times 60. 3 gallons per hour. And so those of you who have fish pumps and stuff, you know that's a fish pump number. That's a fish pump number. So there we go. So those, and you just want to be able to do this. You don't know yet. You don't know what a good number is. You just know that you're going to have to look at this number eventually and figure out if your design is okay. And maybe change your design. I'm going to use 1/2 inch. I'm going to use 3/4. Maybe you'll use 4-inch pipe and pull that thing back really slowly or really fast and just suck the river dry. Maybe that's what you'll do. You don't know, but you have to calculate to know how well your pump is working. Cool? I'm going to turn